So now we're going to look at using y equals mx plus b to graph. So when we're graphing y equals mx plus b, we can do this in two ways. So we can create a table of values, or we're going to do it a separate way without a table of values. So first, we're going to look at how to do it with a table of values. So let's take a look at our equation. 2x plus 2. Sorry, y equals 2x plus 2. So how do we create a table of values from this equation? So our step one is to draw a table of values. Then we're going to be picking some y values. So what I would recommend is you probably pick around 6, 5, 6-ish. So I would probably do -2, -1, 0, 1, 2. I guess that's 5. You can do more, whatever you would prefer. And then we're going to substitute these x values into the equation to get our y values. We're going to do these, don't worry. And then we're going to write the y values into the table of values and then plot the points on the graph. So what I mean by, I'm going to just delete that. Our first step is to draw our table of values. Our second step is to write down some x coordinates, or numbers, sorry. -2, -1, 0, 1, and 2. And then we're going to substitute these into this equation where it says x. So what we're going to do here is substitute the first one. So we'll go with 1. And we will do y equals 2 bracket. We're going to substitute this first one, so -2 plus 2, which equals -4, because 2 times -2 is 4, -4, plus 2. So -4 plus 2 equals -2. So when x is -2, y is also -2. So then we are going to put our y as -2. Let's do it for the next one. So y, we'll write it, the equation down, y equals 2x plus 2. And we're going to substitute this -1 into where the x value should be. So -1 plus 2. This gives us y equals 2 times -1 is -2 plus 2. So -2 plus 2 gives us 0. So we are going to take the next one, next plot, or put on the next point, put it there. So when x is -1, y is 0. And we can do another one. So let's plug in our 0. So y equals 2 times 0 plus 2. I'm just going to move this over here. Which gives us 2 times 0 is 0 plus 2. So y equals 2. So when x is 0, y is 2. And we continue to do that for the rest of them. And you will get this t-chart. So we now created a table of values from our equation. And from here, we can now plot these points. So we're going to go for the first one. I'm going to zoom in a little bit here. So when x is -2, y is -2. So we're going to take our point, and when x is -2, so we go 1, 2 to -2, y is also -2, so we go down 1, 2. So our first point is there. And when x is -1, y is 0. So we take this and we go x is -1, y is 0. So it doesn't move. So we stop there. That's our second point. Our next one is when x is 0, y is 2. So we go up 2 and we'll drop it there. When x is 1, so we go over 1, y is up 4. So 1, 2, 3, 4, and we plot it there. And the last one, we go over 2 and up 6. And we have now created a graph. I would put the line of best fit through there. So let's practice. So here I've given us another equation. So y equals 3x minus 1. So I've already done step 1 in starting my t-shirt. Step 2 is I put in some x values. So -2, -1, 0, 1, and 2. So now we are going to plug in these x values into this equation to get our y values. So let's do the first one. So y equals 3x minus 1. So we're going to substitute this -2 into here, into the x value, and do the equation. So y equals 3 times -2 will give us -6 minus 1. So I'm going to slide this back down here. So -1 minus 1 gives us -7. So when x is -2, y is -7. And we're going to do it again. I'm just going to number this. And we'll do number 2. So we're going to take this next value here and substitute it in. So y equals 3, -1, minus 1. And then we calculate it out. So 3 times -1 is -3 minus 1. And -3 minus 1 is -4. So when x is -1, y is -4. And we continue to do this. We'll plug in 0. So y equals 3 times 0 minus 1. I'm just going to bring this down to y. 3 times 0 is 0, minus 1. So our y is equal to -1. And we'll do it again for the other ones. I like to number mine like this just for organization. I would recommend it. So let's write this in. We'll substitute in positive 1. So 3, plug in 1 there, minus 1. So y equals 3 minus 1, because 3 times 1 is 3. And don't forget, this is where BEDMAS comes in. I should have said that earlier. So multiplication comes before you minus the 1. So 3 minus 1 is 2. We'll set this over here, and then we got one more. So y equals 3, substitute in the 2, minus 1, and then y equals 3 times 2 is 6, minus 1, and 6 minus 1 is 5. So these are our points right here. We have now finished this, and we can now plot the points on our graph. So we'll take one of these graphs here, and we're going to plot these points. So let's zoom into this one a little bit so I can grab these. So when x is negative 2, we're going to go down to negative 2. Y is negative 7, so we're going to go down to negative 7 and drop it there. The next one, when x is negative 1, y is negative 4, and drop it there. When x is 0, y is negative 1. Go to the next one. When x is, oh, this is going to start moving on me, it's squished. When x is 1, so we go over 1, y is 2, so we go up 2. When, oh goodness me. When x is 2, we go over 2, y is 5. And then we would draw the line of best fit. And that question is done. You're going to have, oh, I definitely thought there was another practice question. So I'm going to go on to graphing without a table of values. So do you realize how long that took us to complete? It takes quite a long time, but some people need to do it. I used to do it all the time. It is still a good route to go, but there is a shorter way to do it. So the first thing we're going to do before we do any of that is review slope. So quick slope review. Slope is rise over run. And in this equation, we had said the first difference is m. But the first difference is also another word for slope. So when we talk about, I think you had this conversation, or not conversation, lesson in grade 9. Slope is equal to, so m is equal to slope. I'm just going to move this here. And slope is equal to how much it rises from one point to another and how much it runs from one point to another. So when we're talking about the slope of this line, so we're going to go from point A to point B. So we have to find out how much it rises and how much it runs. So we're going to assume that these go up by increments of 1 for the sake of this. So we're going to go from this point, it goes up 1, 2, 3, 4. So our rise, so m equals 4 over, I'm just going to move this out of the way, So we're up 4, and how many is it across? 1, 2, 3, 4, 5, 6. So our run, so it rises 4 and it runs across 6. So our slope is 4 over 6. So when we ask what slope represents, it just represents the steepness of the line. So we're just trying to figure out how steep this line is. And to do that, it's represented by m. So now we are going to go and learn how to graph without a table of values. I lied. We're going to go over slope again. So when we look at this equation here, our slope, if we're going to represent, our equation is the same all the time. So y equals mx plus b. Okay? So this, whatever is in this spot where m is our slope. So when we look at this here, our slope is this right here. And because it's just a 2, it would be represented as 2. But it can also be, it goes up 2 and over 1. So it rises 2 and it runs 1, because 2 is the same as 2 over 1. So when we look at the next one, again, we're going to do the same thing. Y equals mx plus b. This spot is 1/2, so our slope is 1 over 2, which means it rises up 1 spot and goes over 2. So if we look back at here, it would be going up 1 spot and over 1, 2. And that is how we find out our slope. Now let's take a look at graphing without a table of values. So what do we know about this equation? When we look at this equation, we know, again, we just talked about it, that this is the slope. So it rises 2 and it runs 1. And we also know from y equals mx plus b. So b, right, we're going to go back through. So m is slope, or first differences. Sorry. Y is our dependent. X is our independent. And our b is the y-intercept when x is 0. So we know the slope, and we know the point, bracket, when x is 0, y is -5. So we know that point. So what we're going to do is go and graph this part. So we're going to start with the y-intercept. As we can see, we've already graphed it here. But what I would do is the very first point I would plot would be 0, -5. So when x is 0, y is -5. And we know the slope goes up 2 and over 1. And then we will plot that point there. And then it goes up 2 again and over 1. And it continues up 2 again, over 1, up 2 again, over 1. And so you can continue to create a line. So now we're going to practice. Sorry. So first thing we're going to do is figure out what our slope is. So our slope is this position here. So our slope is 1 over 2. So again, what that means is it's going to go up 1. So this is going to be our rise. And it's going to go over 2. So this is going to be our run. Right? So we're going to have it rises 1, runs 2, and our y-intercept is this right here. So our y-intercept is 2. So what that means is when x is 0, y is 2. So we're going to start by, oh, I did not have this one organized. That's okay. We're going to go like this. We're just going to zoom in. So we're going to plot this on the first point, 0, 2. So when x is 0, y is 2. So that's our first point. And then we can now do another point. I don't know why I keep check marking those. By going from here and going up, our rise is 1. So we go 2 to 3. And our run is 2. So we go over 1, 2, and drop it there. And then we keep going. So we go, our rise is 1, and then we go over 2. Next one. From this point, our rise is 1. We go over 2, and we drop it there. And you can keep going and keep going and keep going, and your graph is done. Put a line of best fit, of course, but how much easier and how much shorter was that than not using a table of values? So we're going to practice again. So our slope for this one is always in the m spot. So even if you have to write, if you have to look at this and then you write y equals mx plus b, our m is always our slope. So our slope is -3. So that means our rise is -3. And our run is 1, because there's always a 1 underneath here if it's a regular full number. And our y-intercept is in the b spot here, so it's -6. So when we're plotting this, let's see if I can, yes. We're going to plot our y-intercept first. So what this means, again, and write this beside it if you have to. This means when x is 0, y is -6. So when x is 0, y is -6. And then we must get another point. And since our rise is -3, it means we go down 3. So 1, 2, 3. And our run is over 1, which would go there. And you would keep going down to create a line of best fit. But what you can even do here is take a ruler, connect these two, and plot the points that it goes through. So don't forget to do your line of best fit. I did not make this long enough for us to continue downwards. So now we're going to take a look at word problems. So we don't have much more to go through, I promise you. So you will see word problems like this. I'm just going to bring it up over here. So you are going to see word problems. And the first thing I would recommend is to figure out what is your dependent and what is your independent variable. So our example is a satellite TV package from BlastView costs $75 to install and then costs $25 per month after that. So what it wants us to do is graph the relationship. So do a graph and give an equation. So what we're going to decide first is our dependent variable. So our dependent variable is our cost. This is because our cost depends on how many months we have this package. So our cost is dependent on it. And our independent is the amount of months we keep this package for. So what we're going to do first, like I said, you can skip this step, but for the sake of this lesson, we're not going to. So we're going to create from 0 months, 1 month, 2 months, 3 months, 4 months, 5 months. What do I have? That's going to, I have it's going to 5 months. Perfect. So we're going to put our months, because it is the independent variable, on the left-hand side. And we're going to put our cost in dollars on our right-hand side. So at 0 months, how much does this satellite cost? Our cost is initially $75 to install. So at month 0, we are paying $75 for the satellite TV package. So we're going to put 75 as our initial cost. Sorry, I just got excited apparently. And then from here, it now goes up $25 per month. So you're going to be adding 25 each time to the month before. So 75 plus 25 equals $100. So we're going to put that here. And then $100 plus 25 equals $125. Apparently I'm winning a lot of Amazon things today. And then we're going to fill this out here. So we're going to go up another $25. So this right here is, I wonder if I can create these lines. It's not wanting to work for me very nicely. So it goes up $25 every time. So as we can see, this is now our first difference, and our first difference is also our slope. So we would continue to do this, and we would get our T-chart completed. So as we see, we've gone all the way up to 5 months. And then from here, we can now plot this on the graph. So I'm going to zoom in. So at month 0, our cost is $75. So at month 0, our cost is $75. At month 1, our cost is $100. Or sorry, yeah, month 1, our cost is $100. There. At cost 2, or at month 2, our cost is $125. So we keep going, plotting it. There. Check mark. At month 3, our cost is $150. We're going to keep going, so on and so forth. And at month 5, it is $200. And then we will put a line of best fit through that. and it is a straight line. Now we're going to create our equation. So our equation is always written in the form y equals mx plus b. So when we take a look at what our y is, so our y is always on the right side. So it is our cost. Our m is, we found it up here, it's our first difference, which is 25. You can also figure it out as, it told us $25 per month, but you can always do, it goes up how much, it goes over how much, so it goes up by $25, over by 1 month, which gives us our slope. So rise over run. Our x is equal to per month on this side, so we'll represent it with an m. And then our b is the point when x is 0. So it is $75. We don't actually need that. So when we write this equation down below, our equation is y equals, cost equals 25m plus 75. You can get all this information from just the question itself. You don't actually have to do the whole T-chart if you don't want to, but I like to make sure that I got everything correct. So that is our lesson for today. I have practice questions and you have an assignment up, and the rest should be written in announcements for you guys. I hope you're able to understand it. If not, please contact me. We can video chat, or I can send you emails explaining things.